In 1971, Stephen Hawking proposed that there was another way that black holes could be formed without any precursor stars at all, but rather from density fluctuations in the very early universe. He called them primordial black holes. During the radiation-dominated era, when the universe was still an energetic plasma of photons and matter, major inhomogeneities, essentially lumps of matter, would have resulted from the inflation and subsequent reheating of quantum irregularities in the nascent universe. Gravity, already inherent to the universe, would have acted on these density contrasts, collapsing vast areas of gas down on itself, all over the early universe. However, there was only around a 1-second window after the Big Bang when this could have happened, before the universe expanded and cooled to such a size that gravity was no longer effective at pulling together matter into these black hole prisons. After that, the universe would have to wait many millions of years before a new black hole would form through the death of stars. But these primordial black holes could be the seeds for the otherwise unexplainable black holes we are detecting today. The problem is, although this theory seems consistent with our understanding of how matter behaved in the early universe, we have very little information on when exactly they did so, and how large they could have grown in that 1-second window. And so how do we find and identify them, if they do exist? In the 1970s, Stephen Hawking also theorized that black holes do more than just swallow matter and grow ever larger. He suggested they could lose some of their weight through what became known as Hawking radiation. This weight loss is faster the smaller a black hole is, and the runaway acceleration of radiation would ultimately lead to the obliteration of a black hole in an explosion equivalent to 1 million megaton hydrogen bombs. Any black hole that was less than 100 billion kilograms in mass could be expected to decay away within the age of the universe, so scientists have begun searching for these characteristic explosive death throes with instruments like the space-based Fermi Gamma Ray Telescope. Other potential methods for searching for these elusive primordial seeds involve looking for microlensing and magnification of stars and galaxies as the black holes pass in front, or trying to detect the destruction of dense stars caught in the primordial's gravitational wells. But all these studies have accomplished so far is to rule out certain size ranges, leaving an ever-shrinking envelope of possibility for how big primordial black holes can be and when they formed.